Hello, let's learn about linear and quadratic systems. This topic is also sometimes just called nonlinear systems because a nonlinear system is where you have a system of equations and one or more of them are not linear. So on the SAT in particular, linear and quadratic systems are very common, and they can look like this. You might remember that one of the ways to treat a system of equations is graphically, and that is you're looking for the point of intersection. So imagine a linear and quadratic system. It would look like a line and a parabola. There are three possible outcomes then. Either the line and the parabola do not intersect, in which case the system has no real solutions. I should have said no real solutions. Whoop. Or the system has two solutions with 2 points of intersection, or a repeated solution, in which case you have a beautiful line that's tangent to your parabola like this. So let's look at an example. This example is taken from a practice test. And you can see here we have a quadratic equation and a linear equation. And there's apparently a solution. So how do you solve a system of equations? Well, you solve a system of nonlinear equations just like you would solve a system of linear equations, that is either graphically or by substitution or by elimination. In this case, probably substitution is the easiest method. So go ahead and pause the video and try to solve this. All right, let's go over it together. So it seems easy enough to substitute in for y here, so that's what I'm going to do. 2x squared plus 6 equals 2x plus 6. Move everything to one side and set it equal to 0. Why? Because that's how you solve quadratic equations. Let's do factoring. Like so, and we get x equals 0 or x equals 1. Each of these x's has a corresponding y value. You can calculate the y like so. So, for example, if x equals 0 and we substitute that in here, you'd get y equals 0. So you get the solution at the point 0, 0, also known as owl face. If x equals 1 and you plug that in here, you get y equals 1, giving us a solution at the point 1, 1. So out of the possible outcomes, we got the two solution case. So which one do we want? Well, they tell us the one where x is greater than 0, so that means the 1, 1. What's the product of x and y? 1 times 1 is 1, so the answer is A. Easy peasy. These questions are free points. So when you see one of these on the SAT, say, yes, thank you very much. Here's a question that I made up myself. Here we have a linear quadratic system, and the question is, for what value of k does the system have one solution? So imagine this graphically. You have the line y equals 2x, which is some sort of line through the origin with a slope of 2. And then you have the parabola y equals x squared plus k. And what you're looking for is for them to have one solution, which means a tangent line. Boop. Now, if your equation quadratic was lower down, there'd be two solutions, or higher up, and there'd be no solutions. There's some exact value of k being, of course, this y-intercept right here, that causes this system to have exactly one solution. What is it? Well, if you're feeling brave, pause the video and try to find it. Okay, let me start by giving you a hint. So let's start by solving the system. Imagine doing substitution, plug in the y for the y, get x squared plus k equals 2x. What do we have here? We have a quadratic equation. So now we're looking for when a quadratic equation has one solution. Let's go ahead and set it equal to 0. Do you remember from our earlier lessons how to find out or how to tell whether a quadratic equation has one solution? If you think maybe you do, then perhaps you could pause the video and discuss, or try and solve this again. Okay, so the trick is to use the discriminant. One of the things we learned about quadratic functions was I'm lost. The discriminant. We use the discriminant to tell how many solutions a system of equations has. In particular, the case where you have a repeated root is when the discriminant is equal to 0, because you get in the quadratic formula, minus b over 2a plus 0 and minus b over 2a minus 0, which are in fact the same solution. So that's what we should do. Use the discriminant. B squared minus 4ac must equal 0. That's what I'm going to do. So plug in the b. A is 1, c is k, and you can solve 4 minus 4k equals 0, which gives you k equals 1. So k equals 1 is the exact value that will cause the system to have one solution. Pretty cool, huh? Yeah. All right, here's another example from the SAT. Go ahead and pause the video and try to solve. Okay, let's go through this together. Doing the substitution, I get x squared plus 3x minus 7 minus 5x plus 8 equals 0. Let's combine like terms. X squared minus 2x plus 1 equals 0, and this is a perfect square, which means there's going to be one solution, because when you do the square root of 0, you get 0, and you get x equals 1 as one solution. Bam. There are exactly one solution. Okay, like I said before, these are free points. Wow, when you see these on a test, just say thank you and move on. All right, I have some other examples here. This is from Khan Academy. And here they give you a line and they give you a quadratic, and which of these quadratics gives you some sort of parabola will have solutions at these points. So that one's kind of fun. Here's a solution where our problem that's basically just very straightforward. Which of the following represents the solution? Here's one where you have a couple of curves. You have 3 curves, and a system of 3 equations only has a solution at points where all 3 equations are true. So that's what it means to be a solution to a system. The values of x and y have to satisfy all of the equations that are in the system. So for example, on our graph, this point here at -1, 0 is not a solution to the system because it only satisfies the circle equation and the quadratic equation. It does not satisfy the square root function. Basically, there's a solution point here, and you see that satisfies all 3 equations because it's all on all 3 curves. So this point, 2, 3 is the only solution, and the answer is 1. So I just wanted to point that out about systems of 3 equations. If you want to discuss this or ask any questions, now's the time. Here's another example. This doesn't look like the right answer. I don't know why this is highlighted. So this is a random screen snippet, but this is an example of where you have a quadratic equation and this is an exponential, as you can see here. Now, systems that involve a quadratic and an exponential or a linear and exponential you're not going to be able to solve these by hand unless the answers are whole numbers. There's no like general algebra technique. Like if you try to do substitution here, you'd get stuck. You wouldn't be able to solve this, even using logarithms, which aren't on the SAT. So, yeah, this one is to be solved graphically. So basically you can see there's an obvious solution there at 2, 3. So this is the right answer. Feel free to ask any questions now if you have them. All right, that's it. There's a practice section on Khan Academy called Linear and Quadratic Systems. So what I'd like you to do right now is head over to Khan Academy and try this Linear and Quadratic Systems practice. This is under the Passport to Advanced Math.